we toss a coin 5 times independently, and the question is, what's the chance the total number of heads in the first 3 tosses is less than or equal to the total number of heads in the last 2 tosses? How on earth do we figure this out? We could start by naming things, right? It's always a good idea. Introduce some symbols. Give things a name. All right, so let's let x be the number of heads in the first 3 tosses. And let's let y be the number of heads in the last 2. So what we're asking is, what's the probability that x is less than or equal to y? Okay? So that's some event. What are the possibilities for x and y? What can they each be? How many heads can you get in 3 tosses of a coin? 0, 1, 2, or 3, right? Okay, the possible values are 0, 1, 2, and 3. What are the possible values here? 0, 1, and 2. Okay. What combinations of values correspond to x being less than or equal to y? All right, so any of those, there's 4 possibilities for the first and 3 possibilities for the second. There's 12 possibilities in all, right? They're not equally likely, but there are 12 possibilities. Some of them correspond to x being less than or equal to y. Some of them don't. So for example, if x is 2 and y is 0, x is not less than or equal to y. Okay. If x is 0, y can be anything, and x is less than or equal to y. Yes? Okay, so let's just make a little table, x, and then what are the possible values of y that corresponds to x being less than or equal to y. So if x is 0, y can be 0, 1, or 2, and x is in fact less or equal to y. Yes? If x is 1, y can just be 1 or 2 in order to have x less than or equal to y. If x is 2, y can only be 2, or else x is not less than or equal to y. And if x is 3, y can't be bigger. Yep? So these are the outcomes that correspond to the event that x is less than or equal to y. So far, so good? Okay. Are these mutually exclusive? Yeah. If x is equal to 0, x is not equal to 1. Right? These rows, if you like, are mutually exclusive. Yeah? Okay. So if I can find the probability of any of these 3 things happening, right? This is really 3 outcomes. It's 0, 0, 0, 1, 0, 2. Right? And this is 2 outcomes, 1, 1, and 1, 2. If I can find the probability of any of these 3 things happening, I can add it to the probability of either of these 2 things happening and add it to the probability of this happening. And what I've got is the probability that x is less than or equal to y. Okay? So how do I find this? Well, what's the chance that x is in fact? So now I want to now divide this up in another way. What's the chance that x is 0 and y is 0? It's the intersection of two things. Chance x is 0, the intersection of the event that x is 0 and the event that y is 0. The number of tosses and the number of heads in the first 3 tosses is independent of the number of heads in the second 2 tosses, right, in the last 2 tosses. Yes? So the event that x is 0 is independent of the event that y is 0. So I can find the probability that x is 0 and y is 0 by multiplying the chance that x is 0 times the chance that y is 0, using the independence.